beyond today's presentations. So I have 11 slides here, but it will be very quick. The outline is, I have some information items for you. The other two is question about fractional calculus and complexity quantification and regulation problem. And later on, what is the most important research effort? I hope I can get inputs from you. I can serve as your secretary and type, but then we have a recorder here, we can type later on, and we summarize up our discussion and research directions and whether the industry interests. So information items, this year we have San Diego Symposium on Fractional Derivative and their applications at ETA. This event attracted more than 50 submissions, and I'm one of the organizers for this. So there are a variety of topics very interesting, and hopefully I can release a list of papers in this symposium very soon, because the review process is done. Later on, we are going to have International Federation of Automatic Control, Fractional Derivatives and Application 2010. That will happen in Spain. See, you can see this is false, this is also false. You can see the odd year and the even year, we have this type of swapping. One is under SME, one is under IFAC. So just for your information, hopefully I will see some of you in Spain in this event. This will be really good, I believe. It's in a good person's hand. So you can see, and that's just reminding you, I started in 2003 and 5 and 7, 9 and 4, 2006 and 2008. I came back from, 2008 is in Turkey, Ankara, then Spain, then China. Okay. Then if you like, we can together as a team say, let's do it Salt Lake City, somewhere like 2014. So anyway, it's happening, and I attended every one of these, and I know people in this community pretty well. And another information item is about a book we published last year, 2007 and 2008. I have another one, 2007. These two books, all in English, and it has some chapter or something related to fractional calculus. Okay. And this gained a very favorable review in IEEE Control Systems magazine. And this monograph to appear in a later 2009, and it's being the contract is being signed. So, and basically, we are going to make some case regarding industry application. So, research directions, what to do? More physics. I can feel the need about more physics. It's not just equations. Or more application scenarios. In biology, how to interpret this, how to convince the biologists that fractional calculus is useful. And I know you convince a lot of physiologists, physicians.
Yes.
Yeah, I agree. But the biologists, they are very stubborn. Anybody here? Sorry. Yeah, I know. I tried, but it's hard to make the communication. So, but
the difficulty is you have to learn their language.
Yeah, that's true.
In order to convince them to learn yours.
Right. Especially this interest is my part-time interest. So, I don't have enough time to chase them. So these are the two questions I want to understand better in the next 10, 20 years, and maybe 30, 40, 100. So, as I just said, the complexity in front of us is increasing every year, and the information is exploding, and we can achieve way much more than before. And because Professor West said that when you see complexity, you should see power, and vice versa. So then when the things are getting to a point, complexity to the point, then you will see obviously the power. So the question is, where is the switch? How complex is complex? It's considered as complex. And how to measure it and how to calibrate it. you measure, then you need to calibrate whether you're telling the true story or you distorted it. So I'm not sure. There are a few ways, like the slope is one of them. Is there any others? You invented diffusion, DEA, diffusion entropy analysis. Diffusion entropy. I haven't touched this one before. I'm going to have a closer look later on. But beyond that, what else? So,
Well, a lot, see, the problem is not what we don't know. The problem is what we know that's wrong. And that's most of our education is wrong.
sorry, don't tell others.
And it's a matter of sorting that out. For example, if you look in the people that took fractal seriously, or take fractal seriously in the fractional calculus in the physiological community, they look at time series and they analyze time series to get the slope and the scaling parameter, right, which is the reasonable thing to do. And so they developed techniques, and one of the techniques that they developed was detrended fluctuation analysis.
I heard of that.
The difficulty is that detrended fluctuation analysis has a basic flaw in it. And virtually 80 to 90% of that community has adopted this as the method of choice. And it's because they weren't the people that invented the method. And so this is a method that's prescribed for them that they can get programs for, and they can run their data through it, and they can get out a scaling parameter. And if you don't look at it critically, then it looks like, oh, I've got the scaling, and then you go about interpreting the scaling in terms of what we've been talking about. And it's just, it's not true. Let me give you an example.
Okay, go ahead.
Detrended fluctuation analysis is, it's a technique for when you have a time series, and the time series
Through this.
sort of looks like this. Right? What you do is,
Better one, through this.
what you do is you take a time interval that's this long, and this is a trend, and you look at the fluctuations around that trend, right? And then you take that window and then you put that through here. Now that's a trend for this piece of the time series. You look at the fluctuations around that, and you do this piecewise through all the data, so you get rid of the local trends, right? And so what you're left with then is if you take all the trends out, is you get this nice flat fluctuating time series, and you look at the statistics of that. And if you do then from the statistics, you take the second moment that we were talking about, the square root of the second moment, and we'll call that f of t. That gives you something that's proportional t to the alpha. And you do a plot of f of t versus log of t, gives you a straight line, and the slope of that line